Does this share screen?
Yes, just a minute. Good morning, Ron. Today we're going hi. Today we're going to do a short introduction to programming in Python. Python is the most popular language for machine learning nowadays, especially for deep learning. Why is it so successful? I think the main reason, I can give two main reasons. One, it's extremely simple and aesthetic. Its creator, Guido van Rossum, created it to be like really elegant and nice and easy to use and easy to learn. And maybe that is a reason for the second reason, which is Python nowadays have a huge support community with lots of packages and supporting code that can help you do many, many tasks really easily. So it's a whole ecosystem. That's the main reason that I can come up with. So I will share my screen now. Okay, you do see my screen, right?
Should I do launch meeting? Or
No, sorry.
sorry. I forgot.
No.
This is your screen,
my
mine.
screen,
Yes.
Yeah. Okay, so let's start. Just let me move that. Okay. We're gonna use a tool by Google, which is called Colab. If you use Google Docs and Google Spreadsheet, it's one of those tools you can find in your Drive. I will open a Colab now. New.
How do you spell it?
Colab. I will show you.
Collaboration.
It's called it's collaborative.
Collaboration.
Yeah. It's a really nice tool. It's let you program in Python and do many, many things without installing anything on your computer from your browser. It is built on a tool called Jupyter, which is also built on another tool called IPython, but you don't need to know all this to work with it. You can just start working. Let's call this document Hello Lord. It is like a tradition in many, many programming languages that the first language is just printing hello world. But I prefer hello Lord because it represents the right relationship between the programmer and the program. So in Python, the first program will be something like that. Hello Lord. Okay?
Did you do that? No, you have to operate the program.
I needed to press this little button here in order to run it. Okay, it runs fine without any bugs. If you ever tried to learn a language, a programming language like Java, for example, you would have appreciated the fact that this is such a simple program, because other programming language, the simplest task to do is very complicated. Okay, so let's start doing something which is in the last lesson we did a loop, right?
I forget.
You remember how to do a loop? It's like for, and you pick a variable that stores the iteration, and you add in, and here you can add a range of number like 7. And now I will do print X.
Range 7 is from 1 to 7?
No, it's from 0 to 6, actually.
Okay.
You will see. I will do something like that. Print x 2x. And okay, what I wanted to show you here that you see line 1 is the declaration of a loop.
Mm-hmm.
It's end with 2 dots, comma, which indicates a starting of a block. A block will be everything that inside this programming component, like inside this loop. So we have 2 printing commands inside this loop. Lines 2 and 3 are inside the block. How do I know that it's the same block? Because it is indented, you see?
He indented it for you.
Indentation.
Yeah.
What,
You didn't do the indentation. It did it on its own.
I did it, actually.
I see you moved and...
Look, I will do here another print, which is not indented. So the done will be away from the outside the block. So the done will be performed once, and the other 2 will be performed 7 times. You understand the difference between being
Yes,
inside a
definitely.
block?
Definitely.
Okay, let's
So
run
you
it.
don't have to say end block, as people do
Exactly,
usually.
and I don't have to say start block. Only the
Indentation does it.
indentation does it all.
Hmm.
This, I think Python is the only language that shows this way of indicating a block. So what happens here, does it make sense? Let me put more space that we can see.
No, not to me. 2x.
Does it make sense?
Not to me. So I would expect 0, 2, 4, 8, 4, 6, 8, and so forth. But
Let's
what?
think about it.
Sorry?
This is a block, right?
Print
So
x. Okay. Print x, and at the same time print 2x. Okay. Yeah, that's clear. Yes. Okay. Okay. Yes. Understand.
So yeah, so this is the first iteration, 0 and 0, 1 and 2 is the second iteration, 2 and 4,
Yes.
right?
Okay. Mm-hmm.
And done is printed only once at the end. But
Yes.
if I will indent this like that,
Mm-hmm.
what will happen?
Yeah, done in between.
Exactly. Okay. So you understand what is going on.
Yes.
Let's start by creating a function or a procedure in Python that tell us if a number is prime. Okay?
Okay.
So in order to define a procedure or a function, you use the...
Sorry, I don't understand the one. Why is the one there? That's...
where? Here?
At the left.
This one?
No. Bring back.
This one.
Yes.
This is just the...
Sorry, I don't hear you.
This is the first line, second line, just the counting of the lines.
So it writes it to you. Okay. You don't.
Yeah, I didn't do that. It's automatic, yeah. So the first line is def. I will call this function is prime.
Okay.
This is a convention name for something which is a predicate. It tells you true or false. It is a function for Boolean value. Okay, is prime, and n will be. So after I will program this, I will be able to ask, is prime 7 or is prime 10?
Yes, okay.
Okay. So do you know a very simple algorithm to know if a number is prime?
On range n, No, but already, yeah, it will be on range n. Look, look.
So we need a
Test
we
if
need
n
a
divides.
we
Yeah.
need a loop, right?
Yeah. So for k, if you wish,
Okay.
in range
range.
n,
Do we really need to check all the numbers until n?
as long as you don't know what is prime and what is not, then yes. You have to check only primes before.
But I don't know which is prime and which is not. But you know that I need to check only until the root of n.
Square root
Right?
of n, yes, right.
Yeah. So I would like to write here root of n, but unfortunately, or maybe not unfortunately, the core of Python doesn't have a square root function. This is something that I need to import, like a package, an extra package that will give me this functionality, because the core function is very minimal. So I will write here import mass. This will give me some mass functionalities.
Okay.
If I don't need mass, I won't do any import like that. So here I will write a mass a dot a sqrt, which is square root of n.
And the square root will give you the integer value. This function gives the integer value.
Great point. No, it will give me a float, and I need an integer value, so I need to cast it actually. So I will do something like that. That's a flow value, the flow value of the square root.
Yes.
Now it's an integer. Okay. Oh, sorry. Okay. So you know what? Let's just write k to see that we are okay. We'll just say print k. This is not the right algorithm, of course, but for now, we'll see if we did. So I will write is prime 7. What do I expect to see?
I don't think, I think you'll just print 1, 2, 3. 1, 2,
1, 0,
1, 2.
0, 1, 2, right?
0, 1,
Okay.
2.
Yeah.
You did.
And
where's the 2? Where's the 2?
Yeah, where's the 2? Right, because range, remember before that I told you that range is from 0 to 6? Range is a closed open range between 0 and not including the last one. So we need to add 1.
Still, square root of 6 is 2. So you have to check also 2.
Now that's because of the range command. The range command, let me show you. Here we did range of 7, right?
The range of 6 is up to 5.
Exactly.
Yeah, but
range does not include the last one. So here we must add 1, okay? You understand? Because range does not include the last one, and we do want to include it. Is it clear?
No, I just don't understand why 2 didn't appear before. It was integer math of square root of 7 is 2.
Yeah, square.
Yeah. So this range of 2 is only 0 and 1, right? Okay.
Yeah, exactly. So let's do it now. I will define it as follow, and now, okay, this is good. But actually, in our algorithm, we don't need to check 0 and 1, right? We want to start with 2 actually for prime.
Okay.
We want to, right? We want to check whether n is divisible.
Because 1 divides everything. Yes. Okay.
Yeah. So we can write here range 2. If we give range 2 parameters, the first parameter will be the first one, and this will be the last one. So But now, okay, I will change it. I will not say 7, I will say 12, for example. So now we expect to see 2, 3, 4, until root of, it's 3 should be the last one, right?
Yes.
Okay, 2 and 3. Okay, now instead of, we don't want to print k, what do we want to do?
Divided by k, but how do you say that it's an int? Oh, I don't know. I mean, do you want to write a program like there exists a k, there exists an m such that
Yeah,
k times m is 12? As
that's the right direction. But we're inside of a loop now. We're going to ask a question. If we want to ask if n is divisible by k, right? So if n, this is the sign of modulo in Python. If n modulo k equals
0, yes.
0, this is divisible by.
Why did you write 2 signs of equality by mistake?
No, it's not a mistake. One sign of equality is actually an assignment, which is a bad sign.
Wow, yes, I understand. It's like the 2 dots are the comma equality.
This is kind of unfortunate. Look, if I do a, which is a variable, equals 17, it's not asking whether it equals 17, it's actually an assignment. I will ask him what's the value of a, it will say it's 17. So this is a semantic of 1 equal. If I want to ask whether it's equal, it's two equations.
Okay.
Okay, so what should I do if I find that n is divisible by k?
Say no. I don't know how you say no.
Yeah, I will exactly return false. There are 2 Boolean values in Python, true and false. And if now I don't need to run anymore, right? I know it's not a prime. I can return this value. Okay, when do I know that it is actually a prime?
If not, then go to the next. I don't know. Don't do anything.
Exactly. If the for loop didn't return any false, didn't stop by returning false, it's true. But look where I put it, after the loops. Like here, I can say return true. Okay. Let's look at the algorithm now.
But it will return true anyway.
No, because return is terminating the function. Okay. When you return a value, it's the end of the function. So if it's divisible by anything, eventually it will return a false. If it reaches line 7, it means it didn't return a false. It meant you should return true. Okay. Is it clear or not?
No, not clear. Why doesn't he? So suppose regardless of what's happening in the inside loop, it goes to the final and say true. No, I mean it will return is the value.
Let's do a simulation in our mind. So suppose I gave it I will ask if each prime is of 3, for example.
Okay.
At the beginning, k will be equal to, right? 3 is not divisible by 2.
Yeah,
so it will not return false.
So it will return true. That's fine. But now try 4.
Okay, 4. I start with 2. It is divided. 4 is divisible by 2. So it returns false.
But won't it return afterwards true when it comes?
No. Returns terminates the function. If
okay.
Returns get out of the function.
Okay.
Okay. So the only way we can reach this line is only if no false was returned.
Okay.
Okay,
After
so
return, there is no return. Namely, if it says return, you don't
after return,
cannot.
there's nothing at all, no
Yes,
function. Yeah, no return, not anything. So let's just check if, so 4 is prime 2, right?
mhm.
This is correct. Let's say 4. Let's check 4. Check 4 is not prime. What about 5? It's prime. Let's make a loop to print all the value, all the prime number until, I don't know, 50. So 4n in. The nice thing that now we kind of enrich the language. We have a new concept, which is prime. We can use it. We can build on top of it. For n in range, like 51, let's start with 2, because 1 is neither a prime or a composite, right?
Mhm.
Print, I will write print n sig is prime n. Okay, so I will print the number, any number between 2 and 50, and I will say whether it's prime or not prime, okay? Are you with me?
Yes, yes, I'm here.
Does it make sense? Let's say.
It's correct.
What?
It does its job correctly. Yes.
Yeah, it's working. Okay.
17 is indeed correct. Okay.
How do you know how many prime numbers there are in a certain range? There is a theorem. What?
It's approximately n over log n, a log
Yeah,
is of
right. And
natural base.
it's
Basically,
also related to Riemann hypothesis, right?
yes, I think. I don't know precisely, but Riemann hypothesis will give you a more precise value, more
Yeah,
precise
right.
approximation.
Okay. So it does the work. Yeah. Okay. Everything works fine. Let's try another example, which will be the second one and the last one for today. Let's do something that solves the roots of second order polynomial. How do you call it? The square root formula?
Yes, okay.
I will write it. Okay. We have LaTeX here, so we can write it like nicely. If I have a polynomial a x
There is LaTeX inside Python?
inside column, which is the tool we're using.
Okay.
Yeah. Bx plus c equals 0. Oh, something went wrong.
You didn't close the,
Yeah,
the dollar signs.
the latter. Yes, right. Okay. So we're dealing with the root of this function. Let's write the formula. We're going to be using it. So x 1 and 2, right?
Mm-hmm.
Equals frac, right?
Yes.
Minus b. Do you remember how you do in LaTeX the plus minus sign?
No, I would write just plus minus.
Let's
Fine.
try. I will write plus minus
No, minus.
minus LaTeX.
LaTeX.
This is what we needed.
PM, okay. Okay.
Okay, so this is a PM. Now we need square.
It's really square root, not integer, yes, okay.
Square. Now, that's the way to do square in LaTeX?
No, SQ art.
SQRT, right?
SQRT, yes.
Yeah, okay. A B there minus 4 4 A C and here 2A.
Yes, got it right.
And I need to
Close
the dollar sign.
dollars, yes.
Is this okay?
Looks okay to me, yes.
Okay, fine. So you program it now. We need to find a good name for that. So a square roots of second order polynomial or square.
They call it roots, they're not square roots.
Roots. Yeah, but the roots of second order roots. Okay.
Yeah.
And it will get A, B, and C, but I want us to take care of all the little cases when we're going to see. Okay, so a function that gets A, B, and C and give us x1 and x2. Okay, how we go about that? What do you think we should do?
Give it a name what you wrote before? No, you didn't. You just wrote the formula. Okay. So you want, first of all, you want, it's not a function because it gives you two values.
What did you say?
It gives you two values instead of one, so it's
Yeah,
not.
yeah. In Python, you can return two values, no problem.
Okay.
Yeah, but this function returns two values. That's correct. But what should we do? We're gonna just
But how do you write a function? How do you do the function?
No, it's just arithmetic
Okay.
theory.
It's now defined because you wrote roots to the ropes. Okay.
Yeah. So let's write like x1 equals. That's equals like, let's put an assignment on it. We'll just write the formula minus b plus we have mass. We already have mass squared SQRT of B. This is the sign for power in Python, minus 4 multiplied by A multiplied by C. I need a parenthesis here. Oops, sorry. Does that make sense? I have a problem. I need to.
Parenthesis.
Does that make sense?
Yes.
Okay, and another one for x2, right?
Yes.
What will be the difference? Only the minus sign here, right?
No.
Is it so? Does that make sense?
Very much so, yes.
Okay, so I will return x1 and x2, both of them.
Okay.
And now we're going to test it. Do you have a good example that you know the answer? We can build it, right?
1, 2, 1, yes.
1, 2, 1.
X
Right?
squared plus 2x plus 1, yeah.
What should be the answer for that?
Minus 1, minus 1.
Okay, we got it.
Yeah. Okay.
Seems to work. What if you gave a number if I put here this, what will happen?
X squared plus 2x minus 1 is 0. So there will be, I don't know. There will be answers. You want plus 4, and then it will be, there will not be an answer.
I want an example with no real solution.
So plus 4 instead of minus 1.
What?
Replace the minus 1 by plus 4, by 4.
Okay. Here, okay. Okay.
What will you do?
I did what you told me to do. I put 4 here.
Yes, and he doesn't like it. He shouldn't like it.
Why not?
Because there is no solution. You have a square root of a negative number. Math domain error.
Yes. Okay. I was expecting like an error which is square of negative numbers, but I got a more general one.
Yeah. Okay.
If I'll just check, I will do mass dot sqrt of -1. Yeah, the same error.
Yeah.
That's how it goes. Okay, let's take care of it in our program. So we'll get something that handles it. So maybe we should put the discriminator in a different variable, right? I mean, all this, let's call it
discriminant. Let's call it this.
Yeah.
Okay.
Do you know how to spell it?
Discriminant, yes. As you see here. Discriminant with a C, yes.
Yeah. Okay. Okay, that's fine. And I will write disk here. And disk here. Okay. I want to ask the right question and to take care of it. So what should I ask?
Discriminant negative, you want?
If disk, right? If it's negative.
If disk is negative.
If it's less than 0.
Return oive.
Pardon?
Return oive or something like that.
Or maybe something more informative. Print something like no real solution, right?
Mm-hmm.
It's not always oive. Sometimes you have complex numbers.
Okay.
Actually, Python has complex number built in.
I'm sure.
Okay. No, it even doesn't require an import or anything. Print no real solutions or solution.
Okay. No real solution.
And I don't want to compute the rest, so I will just do return, okay?
Mm-hmm.
Because I want to terminate the function.
Yes.
So, okay, now let's try. No real solution. Okay, it's working fine. Is there any other special cases you can think of?
What, 0, 0, 0?
Yeah, I was thinking about this 0 here. What will happen?
Okay, so that's great. Yeah, so it's minus.
What will happen now?
It has a solution which is -2.
I agree, but what will happen with our code?
What do you mean with our code?
Our code will work fine?
Yes, sure, of course.
Let's try.
We'll give you -2.
Division by 0. This formula is actually
2 divided by 2a, I forget. Yes.
Right? The formula is correct only for second order polynomial, not for first ones. So we need to take care of this case also.
Mm-hmm, yeah.
Right?
So,
well, you will just dictate to me what to do.
If a is 0, return minus C.
Actually, I don't need to I should do it before computing the discriminator, right? Because maybe it's not necessary. So what do you say if
A is 0?
One equal or two equals? It's not an assignment.
Two equals. Two equals.
Yeah, right. If A equals 0, what should I
return
do?
minus C divided by B.
Right. Return minus C divided by. Now I'm confused.
By B.
By B, right? Okay. And that's it, right?
Mhm.
Okay. So it's a more complicated program than we thought it would be.
Mhm.
Okay. Roots. It worked fine, I think. -2.
Yeah.
Okay. Any other special cases? I don't think so.
I don't think so.
Maybe x1 and x2 is the same solution. Maybe we don't want to return it twice.
Why not?
You're a
important to know that
mathematician.
it's a
Okay.
double.
Yeah, that's okay. Okay, so we'll leave it like that. How tired are we? Do we want another example, or we want to quit now?
You want a cubic?
What?
You want a cubic polynomial? Like what? What do you want to do? What do you have in mind?
No, I was thinking about something like the hive of a more efficient way to find prime numbers that require also data structure, because we didn't talk about data structure. Let's talk a little bit about data structure. Maybe we don't do anything with it, but in Python, we've only seen numbers and string, right? This is a string. Hi. Also, this is a string. It doesn't. In Python I can do it with quotes or double quotes. It doesn't matter. And we've seen numbers. We also multiply a string with numbers, right? Remember we did that?
Okay.
Remember we did it?
Yes.
This is 5 times I, 5 high. But in Python, you also have an arrays, or they called a list. I can say that A is equal 1, 2, and 5, and 7, for example. This is already a data structure, right? It's a list of numbers. If I ask what A is, he will tell me that A is this list, okay? You following?
Yes, I'm here.
This is a list. Okay, I can add an element to a list. A append 17. Now I added an extra.
It will append it at the end. It will know. Okay.
Yeah.
Suppose I want to put it in the middle.
It's also possible. I just forgot how to do it. Let's see. Insert, I think. Let's try.
Okay. Yes.
Insert. Yeah, insert. And I think I need to tell him where to put it, like maybe, yeah, a support index, and 11 I will put. Let's see.
Yes.
You can also have a list of lists. I can do A equals something like that. This can also represent a matrix or something. You see?
Okay, I think I'm getting tired. So
Yeah, okay, we'll quit for today. We
yes.
almost cover everything we need for programming deep learning.
Okay, great.
Okay, so we'll see you next time.
Yes. See you.
Thank you very much.
Bye. Thank you.
Bye-bye. All the best.
Bye.